Good morning, everyone. So we're going to get started. I hope everyone had a reasonable trip here, not too much snow for everybody. And we're going to kick off our 5th Build Stuff this year. As always, we'd like to thank all of our sponsors. Without sponsors, we could never actually have an event. Especially Cognizant, Deathbridge, Visma, and Vix, who are our top-level sponsors. Now, our sponsors have set up lots of booths out there with lots of interesting activities inside of them. There are places where you can code against a fake market. There are places where you can get really tasty coffee, and I'm told the coffee gets tastier every day. They actually have 3 different types of coffee. Go around, visit all the sponsor booths. There's a lot of fun to be had out there. Now, and apparently this clicker doesn't work over there. As every year, we do make large donations to charity. We essentially try to run this event as a nonprofit. This year, our charity is again Clown-Nosed Doctors. The Clown-Nosed Doctors, what they do is they actually go and they have specially trained actors that visit sick children. And what we've donated is a whole bunch of visits to sick children here in Lithuania. Other things that we have laying around, we have a VR area where you can put on a headset and look really uncool. Later this afternoon, here, there will actually be a big panel discussion where we will come and we will actually sit up here on multiple chairs and we will have a discussion. If you go into the far rooms over there, there is a section of old computers and video games. Everything from Ataris to old compact laptops and they all work. And you can actually get in and you can play with them. Our overall theme for this year is the old new thing. You may notice you have an old new thing as your name badge. This is not just a floppy disk. If you push it aside, it is also a USB stick. And there are some files and things on the USB stick, including Acid Warp, if anyone remembers Acid Warp. This will be our 5th birthday of putting on Build Stuff. So tomorrow, there will actually be a big birthday cake during the last coffee break. Which, to be fair, can you imagine how big of a birthday cake you need for like 800 or 900 people? As we did last year, there will also be the opportunity to get your caricature drawn. This is back over by Zeta and Theta. And they will be drawing caricatures throughout the entire conference and then basically putting them up on the wires. What will happen is on the last day, you can then go take your caricature off of the wires and take it home with you. Now, if people have not used it before, for questions this year, so for QA during all the sessions, we're going to be using Slido. Now, you can use this from your mobile device or your laptop. You basically go to Slido, and it will ask you which event you are in. Put Build Stuff LT, and once you do that, you'll get a list of the 5 rooms that we currently have running. So there's Alpha, Beta, Run Stuff, Lambda, and Zeta. Click on the room that you are in. As in here, we might click on Alpha. And then you can actually ask a question. Once you are logged into the room like this, you can also see the questions that other people are answering, upvote them. And then at the end of sessions, we will not be doing questions in this session, but for the other sessions, basically the speaker will have a view of what all the questions are. And then they can go through the questions at the end. You will also notice that there are red, yellow, and green papers outside of every room. This is how we do our feedback. It's not really just the Lithuanian flag. The idea behind it is if you enjoyed a session, you should put a green piece of paper. If the session was then you kind of put a yellow piece of paper. And if the session was then you throw a red piece of paper. And this is how we collect feedback for the speakers from their audiences. We've tried using many ways of doing this with websites and technical things, and it doesn't work nearly as well as just having pieces of paper. Now, with that, I would like to invite up, oh, one more thing. On Friday, there is the charity poker tournament. If people want to sign up for that, you can just let the girls in the front know, and they can get you signed up for it. Now, with that, we have a special guest today who would like to come and introduce people, introduce everyone to the city of Vilnius. So, I will let him come.
Good morning, everyone. Good morning. Good morning, everyone. Welcome to Vilnius. I'm Remigijus Šimašius, Mayor of Vilnius. For those of you who came to Vilnius from other countries, I must inform you that you have chosen the best timing to come to this conference. Because, you know, it's November. It's raining, but it's not snowing yet. It's slippery. When it snows, it melts down immediately. It's dark. It's not Christmas yet. So actually, it's the most lovely month in Lithuania during the whole year. So I hope that you will enjoy this month. Of course, we have some indoors as well. So hope you will have a good time also in this conference and other places. Actually, I would like those of you who are interested in Vilnius and what's happening in Vilnius, we're not just hosting this great conference, and of course we are very proud. It's already 5 years we're having this conference. Congratulations with this. We are hosting today also the grand opening of Vilnius Tech Park, which is a huge startups incubator in Vilnius, like in the outskirts of central Vilnius, in the historical place, but with very modern equipment and modern everything. And it's one of the biggest actually startups incubators and ecosystem in the region. And we're inviting everyone to look, to test, to try. Maybe you'll decide to stay in Vilnius, because November, unfortunately, is passing away. We will have some nice snowy days, then we will have very long days, and Vilnius is a great city to live for, especially for developers who build all this stuff. So developers are in the heart of everything, and especially in Vilnius. We respect them very well, very much. What we can offer? I hope that you experienced already that we have insanely fast internet. Whatever you measure, I mean, broadband or wireless, upload or download, in terms of everything, well, in top 5 in the world, in terms of everything, it's insanely fast internet. We have a very creative atmosphere in Vilnius. Citizens of Vilnius are very unsatisfied with what they have today. Of course, they're proud that they live today better than yesterday, but they know that tomorrow will be better than today. And of course, they're creating everything. We are testing new things. We have a special sandbox initiative in our municipality just to test new things, maybe to fail, that's okay, but also to test in the city, in everything. Not only in the city, also in some more sophisticated areas, like for example, if you would take financial sector, suddenly we have a huge financial sector in Vilnius, starting with huge corporations and also small startups. And when people are going to discuss, for example, how to use blockchain technology, guess where do they gather? Of course, they do gather in Vilnius to discuss those things. And if they want to discuss, for example, legal aspects of gaming industry, so where do they gather? Of course, they do gather in Vilnius. And many other interesting aspects which would be interesting for developers, first of all, but also for other people. So I would like to invite you to test Vilnius, to explore it during November month, because this conference is also one of the diamonds of November in Vilnius. But we also have some other months which are much more nice for people to explore Vilnius. So my words of welcome once again. Have a good time here. Thank you for the conference organizers, and I guess that you have a great time here in Vilnius. Bye-bye.
Thanks. Now, I mentioned that the theme of this year is the old new thing. And having to do the introduction talk I figured right now the old new thing is microservices. You know that you're not cool if you're not using microservices, correct? Everything should be microservices. But what I want to talk about is the long, sad history of microservices. Microservices are not a new concept at all. If I were to go back and look through music, I want you to raise your hand when you think that microservices, the core ideas, were really created. How about some Jason Derulo? How many of you think this is when they came around? Not very many. What about, put a ring on it? No? Maybe some Eminem. Any hands going up yet? Okay, maybe this is too new Eminem and we should go for some older Eminem. So Slim Shady. I start seeing some hands coming up now. What about some Britney Spears? I imagine we're back past university for a lot of people here. What about Dirty Dancing? Oh, now we got some hands coming up. What about Shiny Happy People? Michael Jackson? How about John Travolta? Do I have hands yet? Oh, a lot of hands now. What about the Doors? Okay, quite a few hands now. What about some Marvin Gaye? This is actually the most accurate one that we've gone through so far. And we're going to go through a lot of these bits of history. Before we do that, though, we talk about what microservices are. And a lot of people, they like to associate microservices back over to SOA. But SOA is not new. SOA's been around for quite a while. And SOA was not developed back in the 90s. And we have tons and tons of prior art that go back behind this. Now, before we get into the history of things, I think it's important that we define what we actually mean when we say microservice. Now, unfortunately, if you bring 5 thought leaders into a room about microservices, you'll get 7 definitions for what they are. So I'm going to go with Martin Fowler's definition. Service-oriented architecture is a very broad term and practically meaningless. Microservices is a subset of SOA, with the value being that it allows us to put a label on this useful subset of SOA terminology. Luckily, he breaks it down a little bit more. And he mentions that we have componentization, which is the ability to replace parts of a system comparing with stereo components where each piece can be replaced independently from the others. Componentization, that's obviously new. We've never done that before. Our organization should be around business capabilities instead of around technology. This is actually a really good thing to be doing. We should focus on having smart endpoints and dumb pipes, explicitly avoiding the use of an enterprise service bus. And if you have not seen his old talk on this, you must watch, Does My Bus Look Big in This? This is a common thing that people fail in SOA-based systems. They bring in smart pipes with a really complicated enterprise service bus, and they bake a lot of logic into the enterprise service bus. And this has been proven time and time again to be an anti-pattern. Decentralization of data management with one database per service instead of one database for company. We're going to talk more about this one, but this one smells like false dichotomy to me. And we should have infrastructure automation with continuous delivery being mandatory. By the way, if people are interested in things like continuous delivery and DevOps, there's actually an entire operations and DevOps track. It's the only track that we actually have this year. But what's funny for me is that everything that we've gone through here, they're all aspects of SOA done right. How many of you remember Gorilla SOA? Gorilla SOA encapsulated many of these ideas. And I'll give you a hint. Every time there is a common thing that you understand, and it suddenly has a new name, there's a marketing department that's smiling about that. Now, if I start looking back in history, SOA did become popular in the 1990s. SOA became popular at the same time we had a rise of something known as web services. Microsoft was pushing very heavily on the web services side, and SOA was being worked with by Alexander Pasek, and he found that this was actually a quite decent way of going through and modeling systems that happen to be involved with web services. Now, there's actually a funny story here. Does anybody know why Alexander Pasek felt the need to call what he was doing something new called SOA? It was because he thought that the term client-server had become so overloaded that it had become meaningless. Sound familiar? And SOA became popular because of the coexistence with web services. As web services got popular, and they were largely becoming more and more popular due to their background with Microsoft, SOA became a much more prevalent architectural style. But SOA was not invented in the 1990s. SOA was something he was already doing, and he just felt that he needed to pull out a name in the 1990s for it. It was already an existing architectural style. If I go back a little bit further, we can start seeing some of the things that people were basing SOA on. What about COM and Corba? I know some people here may not be old enough to remember Corba. But back when we were doing this stuff, we were basically doing the same kinds of architectural styles that people are talking about today. But what's funny is, COM and Corba, these were still based on prior art. These weren't the first iterations. If I go back and I look on old mainframes, a very common way of setting up your system would be you'd center it around a transaction log. You would then have a writer process, or n writer processes writing to the log, and you would have chaser processes that would actually chase your log, and then they would go and update shared memory. And then basically other processes could query that shared memory. Does this sound familiar? Oh wait, the system's event sourced. We've been rebuilding this architecture for decades now, but we always think we discovered something new with it. But this was very, very common when we were going back and we were looking at building out these kinds of mainframe systems. But there's other examples of this. How many have heard of an old operating system called VMS? So unfortunately, I don't think that we have an old VAX in the back room. I really wish we had an old VAX just so I could go work on it for a bit. But back in VMS, we had a concept that was known as mailboxes. And mailboxes were a generic mechanism that was built into the OS and distributed, and what it would allow us to do is to send messages between processes. We see this pattern going over and over and over again. But VMS mailboxes were not the first iteration of this kind of queuing system that they had actually built. The same company that built VMS, was known as DEC, or Digital Equipment Corporation, back in 1983 had built out a messaging middleware called Infininet. Infininet is what was later being moved towards the driver towards Corba. Unfortunately, back in 1983, we were still in life without internet. And so you oftentimes had multiple groups doing related work who didn't necessarily know about each other. And aside from the stuff that was going on in DEC, there was also a bunch of people out in Sweden that were doing some similar work. Between 1992 and 1986, they had done a lot of experiments trying to get these kinds of messaging systems working with Lisp, Prolog, and parlog. Does anyone want to guess what that turned into? So they originally tried working with Lisp, Prolog, and parlog to build out these kinds of reliable messaging systems. But they found that none of them were really a good fit. So they decided to build a Prolog-derived language, a declarative language, for these kinds of messaging systems, and today it's known as Erlang. It was released for the first phase in 1987. What's funny for me, and we've actually had him over for conferences before, today we actually have Robert Verding, who is one of the authors of Erlang, who today is building something known as Lisp-flavored Erlang. So he has apparently gone full circle. He started off with Lisp, decided he couldn't make Lisp working, so he built Erlang, and now that Erlang's out, he decided to go back to Lisp and try Lisp again. But if I go look at Erlang, it was based on a lot of other things. One thing it took heavy influence from was Prolog in 1972. But it also took a lot of things from another language. A language that's known as Smalltalk. Smalltalk was done by Alan Kay in 1971. Now, let's think about what a microservice is, and then let's talk about what an object is to Alan Kay. An object is a little computer that I can send messages and tell it to do stuff. What's a microservice? It's a little computer I send messages and tell it to do stuff. Now don't get me wrong, we've completely trashed object orientation for a couple decades, but if I go back to the original version of what object orientation was supposed to be, we're back in very similar space again. And it was happening in parallel, Alan Kay was working on Smalltalk. There was another guy by the name of Carl Hewitt who was building something called the actor model, which I find hilarious today that the actor models are becoming cool again. They're very, very similar to object orientation from an Alan Kay perspective. Mostly what they're introducing is a concurrency model on top of the same kind of model that you're dealing with. But when Hewitt released the actor model in 1973, this wasn't done in isolation. He built all of the stuff on the actor model, and it was all based on work that he had been doing on a language called Planner in the 1960s. And if you go look at Planner, Planner is centered around these things that are there, and I send messages to them. But even before this, we used to do these kinds of architectures with people. Think back to the 1950s. And maybe you watch a movie from back in the 1950s. And for instance, they'll have a room filled with people in front of typewriters. And they had the mail guy coming in and out, and they had in and out boxes in front of everybody. This is the same thing that we're dealing with in all these kinds of architectures. This is not new stuff. We've been working with this now for 5 decades. So why do we think it is that microservices are going to solve our problems today? They haven't solved them over the course of decades. How many of you have seen a project that used SOA and came out as a giant mess? Sprinkling some SOA on a project doesn't make it better. You need to actually understand what you're doing. And over the last 5 decades, we've learned a lot of lessons about how to build out these kinds of systems. First lesson we're going to go through is also known as the first law of distributed computing. Don't. Most systems you should not be going through and distributing. I know people are like, but I want to, and it's cool. And then we can have DevOps. But for most systems, you should not be distributing up front. It turns out really, really poorly in a lot of business systems to try to distribute early. And when you go to distribute, you should be distributing normally for availability. You should not be trying to distribute for scalability. How many of you are doing more than like 5,000 transactions per second? I know there's a few, but if you're not, you can easily run this workload on a single node, unless your cost per operation is very high. On top of that, and I thought I had a quote sitting right here, from a guy by the name of Simon Brown. And he says, if you cannot build a monolith, what makes you think putting networks in the middle is going to help? When's the last time you got a corrupted method call in memory? Or you made a call in memory and it just never called the thing on the other side? Or maybe it took 10 minutes to call the thing on the other side. With networks, these are all very real possibilities. It's much, much more complex dealing with something that goes over a network than dealing with something that happens in memory. The next big thing that we should be focusing on isolation. Try to remember back to the Alan Kay definition of objects. They are little computers that you send messages and tell them to do stuff. They have private memory. Now, if you build a monolith, this does not tend to be enforced. You do not enforce your isolation inside of a monolith. It is normally at best said to be developer discipline. And when we rely on developer discipline, that doesn't always work so well. We start seeing some code over here just going in and directly looking at some things inside of an object over here. And this is a big part of why people were pushing for microservices, because you see, if I put a network in between them, then it becomes very hard for them to do that. But this is not the only solution to this problem. And there's lots of varying levels of isolation that we can get to. Along with this, there is a spectrum that we can choose. And the further we go down the spectrum, the further our costs will go up. As an example, I could run in a single process, an operating system process. And if I did this, my costs would be very, very low. But I have no way of knowing that he's not coming in and looking at my memory directly. On top of that, if I'm hosting, let's say, 7 services inside of a single operating system process, what happens when one of them gets a Stack Overflow exception? Or a out-of-memory exception? It takes down the whole operating system process, it'll take down all 7 of the servers at the same time in a correlated failure. This may not be the best thing that I'm looking for. Now, I could go to the next level. And I could say, okay, so now we're going to run an operating system process per service that I built. And we're going to run them all on the same machine. And now I will get better failure isolation, but my costs are going to be higher because I have to maintain all these processes. I get another benefit. One of my benefits is I can use standard operating system tools to manage my processes. Like going back to the one where we were following the log. I could just, for instance, kill and restart one of the processes, and you would start back down at the beginning of the log if you wanted to. And this is useful. There's other levels of isolation I can go to. I can run a Docker container per service. That's the cool new stuff, right? What that really means is I make it work on my machine, so I ship my machine to production. I could go one step further and I could say that we have a node per service. These are all varying levels of isolation, but each step I go along the spectrum, it increases my overall cost. It is not that you should always go Docker container or node per service. There's a whole spectrum of things that we can choose from here. Now, one thing that's very useful is I don't necessarily need to make this decision up front. And I don't necessarily need to make the same decision in dev as in production. I may want in dev to have a different way that we run things. Why? Because bringing up 19 Docker containers on your laptop isn't very much fun. I may prefer to host everything inside of a single process to make debugging and such a lot easier when I'm running on dev in my laptop. Whereas in production, we may actually go off to multiple nodes. One of the beautiful things is I can delay this decision. This has been my favorite part of people's definitions for microservices. That you must have less than 300 lines of code. How freaking arbitrary is this? My question in response is always, in what language? To be fair, I can go grab Clojure and I can write 300 lines of Clojure that's the equivalent of 3,000 lines of Java. So do we have a baseline that we need to set this off of? So like, if I'm working in Clojure, then I'm only allowed 50 because it's normally about 6:1? How many lines of code you have is meaningless. It's a terrible metric to be looking at. I've had a microservice with over 10,000 lines of code in it before. Doesn't sound very micro, does it? Maybe it's a macro service. To be fair, what it was doing was it had one method on it. It was price option. And what it would do is it would actually price a given type of option in finance. And the code was about 10,000 lines of C code running with CUDA in a video card. Now, I guess I could have distributed that to like 300 lines of code pieces and put networks in front of them for no apparent reason. But what we want to focus on is not lines of code. Lines of code is an utterly terrible metric. What you should be focused on is cohesion. How cohesive is the code that you're putting together inside of the same microservice? How much sense does that code make that it's being put together? And you'll find a lot of people make very uncohesive microservices. But this is what you should be looking at. You should not be looking at lines of code. Lines of code is a terrible metric for anything that it's possibly used for. Unless you pay by the line of code. In which case are you hiring? I can unroll loops manually. And now we talk about deploying and all of our varying ways of deploying. And most people, when they start getting into microservices, they imagine that they need a full DevOps setup, where each team that handles a microservice is involved with their own deployments. Everything is continuously deployed. Yeah, no. There's times that this actually turns out really well, and there's times that this turns out not very well. So, when we start talking about things like continuous deployment, it really depends what your system is doing. How many of you would want to continuously deploy the software that controls a nuclear reactor? Probably not the best idea. If you're on a website, it's like, oh, we screwed over a couple users, there's a bug. We found it, we fixed it. But sometimes a failure can cost a lot. Not only that, but we also have questions like, do you actually have maintenance windows? If you have maintenance windows, why are you working towards getting rid of your maintenance windows? Is this a business driver, or is this you just being like CV-driven development? Not all systems actually need to be able to continuously deploy. To be fair, these kinds of architectures are much easier to continuously deploy, but you may or may not need it, and bringing something in like that, it can actually increase cost by a lot. You have to think about things like versioning, multiple versions so they can be able to run side by side. There is absolute cost associated with this. Now I want to come back to one of the definitions that Martin had given. And that was, we need to have a database per service as opposed to a database per company. How many of you always have exactly one database per service? Okay, so like 2 hands. How many of you have one database for your entire company? Like 2 hands. Normally we don't do either of these. Like there's a lot of middle ground here. Now I can do a DB per service, but a DB per service, it has a cost associated with it. So let's imagine that I've got a customer service, and then I have an orders service. And then my poor stupid business guy wants me to write a report that joins customer data with order data. So now I'm calling both of them and joining it in memory on my own. Of course, if they're both in the same database, I could use this really unusual thing in SQL. It's called join. And then we could just write a report and it would actually work. Then again, how many of you have shared a database between multiple services before? Without fail, what ends up happening? They both start writing to each other's data. And you end up with hidden coupling inside the database. It happens. Why? Because we don't have discipline. So what we're looking at here is a trade-off. If I share a database, it makes joining information much easier, but it runs a risk that we end up with hidden coupling back inside of that database. Ideally, in these kinds of systems, especially where we have low throughput data, we're not highly transactional, I might want to put 4 or 5 different services on top of the same database. You know, they're doing like 2 requests per hour. This isn't anything to do with performance. And ideally, none of them would talk to each other's data. The problem is we lack discipline. And what will end up happening is you do end up with them talking to each other's data. But this is not a binary decision. And very often what we might start saying is, well, for these 5 services, we're doing a database per, but then we got a whole bunch of back office stuff here. And this back office stuff, we're just going to drop it all into one database. We got 7 services on top of one database doing back office work because we want less moving parts, so we want to be able to join on that data. This is common. Remember that it's not just going through and making a binary decision. Almost none of you have a database for your company, and almost none of you have a database for every service. That's where you should end up. You should end up somewhere in the middle there, because it's not binary. It's not this is right and this is wrong. It's there's a whole bunch of trade-offs. One of my favorites I've been seeing lately, containerize everything. Containers are not new. They have some advantages and they have some disadvantages. They give you better isolation than what you get with process. They give you less isolation than what you would get with node per. They solve some problems, they introduce some other problems. How many of you have used Docker? How many of you enjoy networking in Docker? It causes some issues and it adds its own complexity on certain things. Now, it's too bad Brian had to cancel because containers have their own very long, sad history. And I think that's part of what he was going to be covering inside of his talk. What's funny about it is when you go back through them, many of the same people that we found in the history of microservices are also in the history of containers. It's a lot of the identical people. But remember that in general, there are many different ways of reaching isolation. Anytime you start hearing people say you should only use operating system processes, you should only use containers, you should only, there are trade-offs associated with all these kinds of decisions. It's incorrect to just give you an answer and say this is what you should take. Now, of course my clicker doesn't work that far away. And my box isn't showing up here. There is actually a box around that stuff at the top that you can see on the screen, but not on the projector. So one thing I find people have a big problem with is they start doing synchronous communications in their backend between microservices. As an example, I will call him and I will say, HTTP post, and then I will block waiting on a response from him. And this causes a big problem in systems. What happens if he is down? Well, then I'm down too, correct? So normally what we want is in our backend, we want to talk through events between all of our services. We do not want synchronous calls in there. The rule is generally you default to using an event, and if you want to use a synchronous call, you justify why you need a synchronous call there. But by default, what we should be doing is we should be always async, always through events. From the clients talking to our backend, synchronous calls or asynchronous calls are fine. It depends how you want to structure your API. But inside of our backend between things, we should always be using events in an asynchronous fashion and justifying why we're going to go through and use a blocking call or a synchronous call. What we're really talking about here is another trade-off. We're talking about a trade-off between autonomy and authority. If we're sending events, I am now autonomous. If he goes down, I'm just going to keep working with the last piece of information that I actually have from him based on his events. I'm going to continue working. If I'm making a synchronous call over to him, and he's down, when I go to make this synchronous call, I'm going to be down because I can no longer talk to him. Of course, you don't always want to be authoritative or autonomous. There are trade-offs between them. As an example, where might I justify using an authoritative source as opposed to an autonomous source? Well, a perfect example would be Google. So let's imagine Google through events. So they're going to have a cluster that's out there, and it searches the internet for changes. It then raises events up about all the changes on the internet, and your mobile phone subscribes to those. Your mobile phone gets all the changes on the internet coming down to it, and then when you query, it queries locally. What could possibly go wrong with this? This is an example of where I might prefer to actually have an authoritative source. I am querying very thin slices of a very large data set. It's much less of a problem for me to deal with the availability of the authoritative thing than to try to make your mobile phone suddenly turn into 50,000 servers. You won't be able to actually keep all that data on your mobile phone to actually be able to search it. Other examples, we can imagine that we're at a bank and we give people their balance. Now, if I go for an autonomous style, I'm going to end up with multiple copies of your balance throughout the bank. Anytime I have multiple copies of something, that means that they may not agree with each other. Now, I would rather tell you that I cannot tell you your bank account balance right now than to tell you possibly 4 different versions of your bank account balance. I would rather go, oh, sorry, we seem to be having a problem right now. Don't worry, your cards and stuff still work. Than to actually tell you in one place that you have 1,000 euros, and another place that you have 55 euros, and another place that you have 2,700 euros. This is another case where I might prefer to be authoritative. Another place I might prefer to be authoritative is due to security. If you go, for instance, and look at a police management information system, you need to log everything that people look at. Why? Because cops have a tendency of going and doing a background check on their daughter's new boyfriend. At the same time, I can't stop them from doing that because they need the ability to be able to do background checks. So the solution is we'll log everything, and then hopefully somebody will be going through the log and, you know, trying to see why people are doing this, but it doesn't actually happen. But it's an interesting use case that could actually appear one day. But if I have to log everything, if I put out events with this data on it, do I trust that you will actually log that you viewed them? This is another case where I might prefer to be authoritative, because when I'm authoritative, it allows me to absolutely control the security on this. By the way, there is a pattern that you can use with events like this, where I can still push around events to everybody, and manage to keep the security going. What you do is you encrypt them. And then whenever somebody gets it and they want to look at it, you make them call back to you to get the key, and then you log that they got the key to be able to view the events. But I want to stress that much of the stuff we're talking about is it depends. Going through and saying, look, you should build your systems like this is a really, really bad idea. And what makes it an even worse idea is that original thing that we went through, that original definition, doesn't actually work well for many business apps. It's overkill. Going through and managing 30 Docker containers, it's overkill. Your app is doing 100 transactions an hour, and you've got 30 Docker containers you're deploying. We need to remember that all of this kind of stuff needs to be taken and looked at in context. For a huge number of business applications people are working on, you should not be looking at microservices. Microservices are a fad. And I lost my slide. It's no different than what we saw with SOA in the late 90s. It was a fad. Think about how many systems failed miserably trying to apply SOA. It was people that didn't have distributed systems backgrounds going through having read a little book and thought, well, I should start building distributed systems. There are a lot of inherent trade-offs in building distributed systems. And there are systems out there that benefit from them. Some things that you can start looking at to think, maybe I should start looking into this style of architecture. Do you need to be up 24/365? If you said no to that, you probably shouldn't be looking there. That's a mandatory thing that you should have. And to be fair, running 24/365, it's not easy. There's a lot of cost associated with doing it. Why? You need to be able to keep multiple versions of your software running side by side for everything. Which means you can never do things like take something down, migrate a database, and then bring it back up. All of your changes need to be able to run side by side between multiple versions of things. There is a distinct cost associated with this. Now, if we're saying that these kinds of things are largely fads, what should we be thinking about? Well, what we should be looking at and what we should be thinking about are age-old ideas. Instead of learning about the latest microservice framework, I'd love to see you go look at some of that prior art from academia. How about queuing theory? And learning how queues work and the mathematics around queues. It's really useful stuff. It'll help you with things like resource planning. So currently we're at this level, and we think over Christmas we're going to see a 30% rise in business traffic. So how many servers do we need? And if we use this many servers versus this many servers, what will be the time that it takes in order to be processed? What do we predict it'll be at the 95th percentile? Believe it or not, queuing theory actually tells you how to do all this. At the same time, how many of you have an Agile board or a Kanban board at your office. If you go through and read about queuing theory, you'll also learn really deep insights into how your board actually works. This kind of stuff is good to learn. This isn't fad. This isn't information that's going to be invalid 2 years from now. And do you realize they estimate that 50% of what our learning is useless in 5 years? But this won't be useless in 5 years. Other things. What about going off and learning something like pi calculus? Or maybe learning CSP, communicating sequential processes. This stuff isn't going to be invalid in 5 years. This stuff is still going to be there. I would much rather you have you go learn this than to go learn a new microservices platform that will probably be invalid in 5 years. Think about how many times you have used different messaging middleware. And how much learning you've done into messaging middleware that just became invalid very quickly afterwards. Focus on the underlying ideas. CSP, pi calculus, actor model. There's a whole bunch of these things that we can go look at. This is not a new problem. This is a problem that we've been dealing with for 50 years. And in academia, there are tons of beautiful pieces of work that will not go invalid within even 6 months. A great paper to start, if people are looking for a paper. Ordering events in a distributed system. Leslie Lamport, 1978. Sounds like such an easy concept, doesn't it? All we need to do is order events. But it's actually a seminal paper on doing nothing more than ordering events in a distributed system. Believe it or not, it's actually a pretty hard problem. But go back to academia. Check out all of these academic papers. There's a lot of meat inside of these. Go read through Tony Hoare, Communicating Sequential Processes, and realize how it works. This stuff is not going to go away anytime soon. The new microservice framework that you're going to play with probably will. This architectural style, there's nothing new about it. It is a subset of things that people have already been doing, and we've been doing it for a long time. And remember that everything that we talk about is trade-offs. Everything. Understand the trade-offs that you're making. When somebody gives you a binary piece of information and says, this is how you should do things, they're almost always lying to you. There's almost always a spectrum of decisions that you can make, and there's certain trade-offs as you move up and down the spectrum. Try to figure out what that spectrum actually is and what those trade-offs are. Then try to understand how those trade-offs are affected within your context, as opposed to whatever one they're trying to show you from. Now with that, I will thank everybody for coming out. I hope you have a good conference. We'll have lots more sessions, and hopefully they will be good ones for you guys. So, thanks again for coming out, and enjoy the rest of the conference.